Hi, welcome back to College Algebra, Math 111. I want to talk to you this morning about the absolute value function. And let's start with this. Let's start with, what does it mean to say the absolute value of x equals 3? What this really means is that x is somewhere, well, actually x is the set of numbers that are exactly 3 units from 0. Because that's what the absolute value is. The absolute value function is a measurement of the distance from 0. So if we look at our number line, this point right there at -3 is 3 units from 0. And this point right here at 3 is 3 units from 0. So what we see is that the absolute value of x, the absolute value of a number, is equal to that number if that number is greater than or equal to 0, and that the absolute value of a number is equal to the opposite of that number if x is less than 0. And if we write this in a more compact form, what we get is the piecewise definition of the absolute value. So the absolute value of x equals x if x is greater than or equal to 0, and the opposite of x if x is less than 0. This definition will form the foundation of everything we do for the remainder of this section. Now we have some rules around handling absolute values, and let's just summarize those real quick so we know how to handle this algebraically. We can combine the product of two absolute values into the absolute value of the product. We can apply exponents inside or outside, in other words, either before or after we take the absolute value. And we can do the same thing with quotients, because quotients are really the same thing as products. The only caveat we have here when we divide is that b cannot be 0, because we can never divide by 0. Okay? And a couple other things to note. If the absolute value of x equals 0, then that means, and it's a two-way implication, x must be 0. That makes sense, right? But if we've got, so suppose we're asked to solve absolute value x equals some number. Now there's a solution here. Actually, there's two solutions. And it works only if c is greater than 0. Then x must be c or negative c. If you're asked to find absolute value x equals some negative number, absolute values are always positive, so there is no solution there. Okay, let's work an example, and you'll see what we mean here. So rarely are we going to start with just absolute value x equals a number. We're instead going to be doing things like solve the absolute value of 3x minus 1 equals 6. Now what we can do, though, is we can reference this second line here and realize that we've got something inside an absolute value equals a positive number. So that means the first thing we need to do is we first need to make sure our absolute value is isolated, and I'll show you what that looks like in a second, because this absolute value is already isolated. So once our absolute value is isolated, the next thing we do is we write these two statements. So we write, we write 3x minus 1 equals 6, or 3x minus 1 equals negative 6. We now have two equations, and we're going to work each of these equations independently. So I'm going to add 1 to both sides here, and that gives me 3x equals 7. Divide by 3, and I get x equals 7/3. That is one solution. The other solution comes from the second possibility here, which is that 3x minus 1 equals negative 6. So we'll add 1 to both sides of this equation, and we get 3x equals negative 5. Divide through by 3, and we get x equals negative 5/3. Both of these numbers are solutions to our initial equation. And how can we check that? Well, we can plug them back in. So let's check x equals 7/3. Absolute value of 3 times 7/3 minus 1. Well, that's absolute value of 7 minus 1, which is absolute value of 6, which equals 6. That one checks. Now let's check x equals negative 5/3. Absolute value of 3 times negative 5/3 minus 1 is the absolute value of negative 5 minus 1, which is absolute value of negative 6, which equals 6. So that one checks. All right, let's do one more example. Let's do one that's slightly more complicated. Let's solve the equation 3 times the absolute value of 2x plus 1 minus 5 equals 0. All right, the first thing we have to do before we do anything else is isolate my absolute value. So let's add 5 to both sides of this equation. So we get 3 times the absolute value of 2x plus 1 equals 5. Divide by 3, and we get absolute value 2x plus 1 equals 5/3. So I've got something inside an absolute value equals a positive number. So this means that 2x plus 1 equals 5/3, or 2x plus 1 equals negative 5/3. Let's work the left-hand equation first. Subtract 1 from both sides. You get 2x equals, so 5/3 minus 1 is 5/3 minus 3/3 is 2/3. Divide through by 2, and we get x equals 1/3. Or, work the second equation. 2x plus 1 equals negative 5/3. Subtract 1 from both sides. You end up with 2x equals negative 8/3. Divide by 2, and you get x equals negative 4/3. These are the solutions to the equation we started with, and we can check those by plugging them back in. All right, I want to do one more example with you that might look terrifying at the onset, but hopefully I'm going to show you that it's really not that bad. So I've got the absolute value. We're going to solve the equation. Absolute value of x equals x squared minus 6. Okay, deep breath. It's not that bad. We've got an absolute value equals something. Okay, We don't know for sure that that's a positive number, but we can handle this. What this means is x equals x squared minus 6, or x equals the opposite of x squared minus 6. Okay, let's work on the left-hand one first. Move the x over, so we got 0 equals x squared minus x minus 6. Factor that as x minus 3 times x plus 2. And we get x equals 3 or negative 2. All right, now let's work on the second equation here. X equals the opposite of x squared minus 6. So this means x equals negative x squared minus 6. Let's move everything to the left this time. So I end up with x squared plus x plus 6 equals 0. That guy actually will not factor. And in fact, if I were to graph him, I would see that he has no real solutions. And that's okay. Actually, I think I messed that up. Oh, I did mess that up. Look, there's a plus there, which means that needs to be minus. Now he factors. So he factors now as x plus 3 times x minus 2 equals 0. So x equals negative 3 or x equals 2. Now, one thing to be cautious of when working with quadratics, all four of these may or may not be solutions to our original equation. So what we need to do is check these. So let's check x equals 3. Is the absolute value of 3 equal to 3 squared minus 6? And when I'm doing this kind of a check, I always put a question mark over the top until I get to my actual conclusion. So the absolute value of 3 is 3. 3 squared is 9 minus 6 is 3. 3 equals 3, so that one checks. Now let's check x equals negative 2. Absolute value of negative 2, does that equal negative 2 squared minus 6? Well, so absolute value of 2 is 2. Negative 2 squared is 4 minus 6. Does 2 equal negative 2? No, that is false. And so I always use a little symbol that looks like two arrows hitting one another. That's a symbol for a contradiction, and I can cross that guy off. He is not a solution. So now let's check x equals negative 3. Absolute value of negative 3 maybe equals negative 3 squared minus 6. Absolute value of negative 3 is 3. Negative 3 squared is 9 minus 6. That is 3. So that one checks. So this guy is a solution and this guy is a solution. What about x equals 2? Well, we're going to have the same problem we had for negative 2, right? So absolute value of 2 maybe equals 2 squared minus 6. Absolute value of 2 is 2. 2 squared is 4 minus 6 is negative 2. That is a contradiction. And this guy is not a solution. So our solutions are x equal positive or negative 3. Okay, so absolute values are not that terrifying. The key is to remember that piecewise definition, because that's where all of this comes from. And to correctly distribute your negative signs, which was where I screwed up. Okay. All right, I hope this has been helpful. I'll talk to you again soon.